All right, Math 8 students, we are looking at lesson 9.5, Congruent Figures. This is our final lesson in our Module 9, Geometric Transformations. And so we are kind of pulling everything together and understanding how two-dimensional figures are congruent to each other and how they can be obtained by a sequence of rotations, reflections, and translations. And being able to not just create that transformation, but also to be able to work backwards and find out what it was. So let's go ahead and read the essential question here. We are looking at what is the connection between transformations and figures that have the same size and shape. Remember, same size, same shape is congruence. So looking at our explore activity, we're going to go ahead and scroll down here. We are looking at combining transformations. So we are going to apply the indicated series of transformations to the triangle. That's this triangle right here. And each transformation is applied to the previous transformation, so that's important. It's not applied to the original, but to the previous one. We're going to label each image with the letter of the transformation applied, so A, B, C, D, E, F, G. Or E. I guess it stops. All right, so the first thing that we're going to do is we are going to go ahead and reflect across the x-axis. So we've got x-axis here. That is our line of reflection. And remember that we are going to go the same number of units from the line of reflection across the line of reflection. So this first point right here, we're going to go 1, 2, and then across the line of reflection, 1, 2. So that's our first point. And so that second point here, we're looking at this point right here. That second point is 1, 2, 3, 4 units from the line of reflection. So we're going 1, 2, 3, 4 units from the line of reflection for our second point. The third point is 1, 2, 3, 4. So we'll go 1, 2, 3, 4 units from our line of reflection. And then we're just going to connect our points here. Okay, so this is A, because it is our first transformation. Now the next one that we're going to do is B, which is a translation. And we know this from our rules that we have just did in 9.4, that if we are subtracting from x, that we are moving on the x-axis. So this is a translation. And if we look at our coordinate grid here, we can see that the negatives are on this side, positives on this side. So if we are moving negatively, we are moving to the left. So it is x minus 3, which is the same as, 3 units left. So I'm going to take each of those points and I'm going to move each of those points 3 units left. So this first point here, 1, 2, 3. So that's where my new point is. So it's my 1, 2, 3. And this point, we'll move it 3 also. 1, 2, 3. I'm going to connect my points. And this is B. This one's done, this one's done. Now we're going to go ahead and reflect across the y-axis. So I'm going to make this one blue again. And so if I'm reflecting across the y-axis here, I'm going to take each point as many units across the line of reflection as it is in the pre-image. So I can see my first point here is sitting on my line of reflection, so it's not going to change. My second point is 2 units from the line of reflection, so I'm going the opposite way, 2 units. Then my third point here, also 2 units, from the line of reflection. I'm going to go 2 units in the other direction across that line of reflection. And so that's my third transformation. I'm going to call that C. Okay, so then I've got my another rule here, and this is another translation. Since we are working with y, it's going to be up or down. Now, since it is plus y, that means that we are moving up the y-axis 4 units. So from C, we're going to go up 4 units. So each one of these points, we're going to count up. Let's start with my first one here. 1, 2, 3, 4. My next point, I'm going to start with this one. 1, 2, 3, 4. My last point right here. 1, 2, 3, 4. And so that is D. Okay, the last translation that I've got is I am going to rotate 90 degrees clockwise around the origin. So quick reminder here, clockwise is this direction, 90 degrees. And the origin is my center of rotation. So I'm rotating around this point right here. So with rotation, I'm going to take each of my points 90 degrees in a clockwise direction. So my center point here is not moving because it is on my center of rotation. Now this point right here, this is the one I'm going to look at first. I want to move it 90 degrees clockwise. And if you remember, from one axis to the next axis is 90 degrees. It's the 90-degree angle right here. So for me to move this point 90 degrees, I'm going to go to right here. That's going to be my 90-degree movement. So I'm going to put my new point right here. So then I'm going to take a look at my last point here, which is this one. And I want to rotate that one 90 degrees as well. And so I'm going to kind of just remember that these two are connected here. And if this point moved here, this point being connected would move out here, right? That would be a 90-degree rotation for that point. So let's go ahead and draw that point in. And that's my last transformation, and that is E. So here's my original. First, second, third, fourth, and fifth transformation. And the last thing it's asking me to do is to compare the size and shape of the final image to that of the original figure. Do the size and shape change at all in any of these? I'm looking at side lengths. Do my side lengths change? Do my angles change? No, none of my side lengths change. None of my angles change. So these all have the same shape. Oops, let's try pen here. And they have the same size because none of the angles change. But what does change is orientation. Okay, so all of them have the same size and shape, but the orientation does change. So let's go ahead and scroll down here, take a look at that reflect question. It wants to know which transformations change the orientation of figures and which do not. So we can remember that the three transformations that we have worked with so far would be translations, reflections, and rotations. We can look up here if we need that quick reminder of what happened for each of those. In a reflection, we notice that the orientation does change. What was bottom is now top. What was right is now left. In translations, where we slide a figure, the orientation does not change. But in rotation, we can see that that does change again because what was bottom is now top. What was top is now right. So we can determine that translation maintains orientation. We should say maintains original. But I'm going to run out of room here. Reflections, oops, let's spell that right. And rotations do not. And last question we've got here in this Explore activity is make a conjecture. Two figures have the same size and shape. What does this indicate about the two figures? Well, one thing we know is that if two figures have the same size and shape, they are congruent. So since we're talking about transformations, we know that these two figures, since we're talking about transformations, these two figures have probably undergone a series of transformations that maintained their orientation and resulted in the same orientation. So let's say something like one figure is the image of the other. After a series of transformations that maintained congruence. Let's say that preserved congruence. Now you could say other things like a sequence of transformations that turns one figure from one figure to another maintains congruence. But what you want to know is that so you can go through a series of transformations, you can use reflections, you can use rotations, and you can still end up with the same orientation, but you need to make... Okay, so we're going to go ahead and move on to page 3 or 4 here, congruent figures. And recall that segments and their images have the same length and angles, and their images have the same length and angles, angle measures, under translation, reflection, and rotation. Two figures are said to be congruent if one can be obtained from the other by a sequence of translations, reflections, and rotations. Congruent figures have the same size and same shape. So once again, we hear that vocab word, congruent. When you are told that two figures are congruent, there must be a sequence of translations, reflections, and rotations that transform one into the other. So this is kind of summarizing what that last little reflect question was asking. If they have the same size, same shape, then they must be the product of a series of transformations that maintained size and shape. So, looking at example 1 here, we're going to identify a sequence of transformations that will transform figure A into figure B. So if we look at figure A here, we are going to kind of consider how we can get it to figure B. So first thing we could do is we notice that the orientation has been reversed, so we can think reflection across the y-axis. Now that works until we notice that they have different distances from the line of reflection. So we could reflect, but then we also have to translate. So to transform figure A into figure B, you need to reflect over the y-axis and translate 1 unit to the left. A sequence of transformations that will be accomplished by this. And so here we've got that algebraic representation. So it's saying that this is our reflection rule, right? When you reflect across the y-axis, you multiply x by -1 and maintain y. And then to translate, you need to subtract from your x if you are going left. So B wants to identify a sequence of transformations that will transform figure B into figure C. So we've taken it a little bit farther here. So let's go ahead and take a look at that. So we've got figure B here, which is our image of the previous transformation. And we're wondering how we could get it to figure C. So this is all kind of problem solving here. This is kind of like that shapes mod game that you guys were doing the other day. So if you have figure B, and you need to get it to figure C, well, we can see first that the orientation has been rotated. So we are looking at it at least a counterclockwise rotation around the origin, But then we can note that this is different. This is a different distance from our x and y axis, and it's a different distance from our center of rotation. So there also has to be a translation. So there has to be at least rotation and then some type of translation. So let's read what they summarized here. Any sequence of transformations that changes B to C will need to include a rotation of 90 degrees counterclockwise. That will result in the figure being oriented as figure C. However, the rotated figure would be 2 units below and 1 unit to the left of where figure C is. So you would also need to translate the figure up 2 units and right 1 unit, which we can see, which we were discussing. So let's move on to the next page with that in mind. So this continues on a little bit from the previous page, telling us that the sequence of transformations is a 90 degrees counterclockwise rotation about the origin, and so it shows us that rule. It reminds us of that algebraic representation of that, which would be reversing x and y and multiplying that y by -1. And then there would need to be that translation. So to translate right 1 unit, it would be x plus 1, and to translate up 1 unit, it would be y plus 2. Y represents up and down, x represents left and right. And finally, we've got one more example here, C, and we are going to identify the sequence of transformations that will transform figure D into figure E. So starting and finish. So there could be a couple different ones here. We do need at least a rotation, right? And we know we need a rotation because our orientation has changed, where we are kind of horizontally oriented this way with a rectangle, and then we're vertically oriented this way. So we do need at least a rotation, and we also can note that this is a different distance from the center of rotation of the origin than this one is. So there likely needs to be a translation in that too. I would say that we probably need to do a 90 degrees clockwise rotation to get into this, right? And then we need to translate right. So let's read what they told us here. A sequence of transformations that changes figure D to figure E will need to include a rotation. Okay, that we said that. A 90 degrees clockwise rotation around the origin would result in figure D being oriented as figure E. However, the rotated figure would be 6 units above where figure E is. So you would need to translate the rotation 6 units down. So what they did is, instead of rotating, so I was saying we could rotate counterclockwise and then translate right. They're saying that you can rotate clockwise and translate down, and either of those will work. They'll result in the same final image. With their method, the sequence of transformations is a 90 degree clockwise rotation about the origin. So we've got our rules for 90 degrees clockwise rotation, and then followed by a translation. So then we've got our rule here for translation, and that y is affected because they are doing an up and down translation, and it's -6 because it is down 6 units. So now we've got a your turn activity here that we're going to try, and it wants to identify a sequence of transformations that will transform figure A to figure B. So we can determine at least one sequence, and we do see that the orientation of the figure has changed and been rotated, so we look like we do need at least a rotation in here. And so I'm just going to draw a rotation. I'm going to say, well, okay, I think we need a 90 degree clockwise rotation. And so I'm going to see what that looks like. So if I rotate 90 degrees, I'm going to notice right here that this point of this triangle is kind of 2 units and 2 units from center. So that 90 degree rotation would take me to this point right here, 90 degree clockwise rotation. And then I need to determine the orientation of those other points. So I've got a point here that I need to rotate 90 degrees clockwise. And so it's lined up with this first point, but it's rotated. So a 90-degree rotation is going to get that point here. This point will end up here after a 90-degree rotation, clockwise. So that's my 90-degree clockwise rotation around the origin. And so we can see that now the orientation is the same, but I need to translate my shape down to get it into the right location. So this is going to be, let's see how many units I'm going to go. 1, 2, 3, 4, 5. So I need to translate 5 units down. So I'm going to go ahead and just summarize that here. Rotation, 90 degrees, clockwise around the origin. Remember that when you are describing rotations, you need to have direction, degrees, and center of rotation. And after our rotation, we then translate 5 units down. And then I'm going to put the algebraic representation of that. So I need to put my rules in here, and I'm just going to slide this down a little bit. And so my rotation, if my original is x and y, for a 90-degree clockwise rotation, I'm going to multiply my x by -1 and then switch my x and y. So y becomes over here, and my x becomes negative. So that's my rotation. Do clockwise. And then I'm going to do my algebraic representation for my translation. So if this is my original, then I would need to translate down, so it's my y that is being affected, my x does not change. So y minus 5 to move 5 units down. So that is the 9.5, Explore Activities and Examples. And so what we are doing in this lesson is summarizing everything that we know. We're doing sequences of transformations and maintaining congruence and applying that if we know something is congruent, that it must be going through a sequence of transformations that maintains congruence, so translations, reflections, and rotations. If you have questions as you went through this, make sure you write them down so we can go over them in class together. We will do the guided practice next time we meet in class. So that's all I've got for you guys right now. I will see you on the flip side.